Okay, so again, yesterday we did the Unit 9 test. If you didn't take it, yesterday, you should be taking it now. You can use your notes in your review, it's fine. But we're moving on to Unit 10 today, okay? You should have got your progress report over there by the door, and you want to think about getting missing work done and turned in, yes? Now, can you, like the warm-up says, graph this function? So the function is what we call a logarithmic or a logarithm, and it has log in it, okay? It's a log base 10 of x. So in your calculator, if you go to a new document, don't save, number 1, okay? Sorry, it was number 2. Okay, to get log, do you see right here next to the number 1, there's a 10 to the x button, okay? And right above that, you see a little log, okay? That's where the log button is. So you have to press Control 10 to the x. So I'm going to press Control, and then right here, 10 to the x. And you should see that it makes log, and it has a space down here in the base, and then it has the parentheses. So remember, we are graphing log base 10 of x. So in the little one down here, I put 10, go to the right. In the parentheses, I put x. I hit enter, and you should get this graph, okay? Now, do you see how it's going up and to the right slowly? It's going to keep going up and to the right forever and ever. But do you see how it makes a sharp, steep decline, and it does not cross the vertical y-axis, okay? Once again, this is what's called a asymptote. It does not cross this y-axis, okay? So all I ask you to do is draw a sketch of that. So just do your best to draw a sketch of that. It cannot go past the y-axis. Something like that, okay? For your warm-up today. Okay. So has everyone sketched something like that from what we saw right here on the calculator? Cool. While you're making sure you have that, I'm going to pass out your 10.1 notes, or someone is going to pass them out to you. Here we go. You pass it out. Actually, right. Does everyone have the 10.1 notes? Okay, here we go. Follow along with me. This can be done sooner than later if we follow along. Cool. All right. So do you see how it says y equals a log little b, little base, parentheses, x minus h plus k. Now, this should look familiar, okay? When you see insiders, what do we know about these insiders? They lie, right? So that h on the inside is a lie, and just like before, it's a horizontal shift. H for horizontal, it's a lie. And then k out here by itself is vertical, k, and it goes up and down, and it's no lie, okay? So we're going to talk about these transformations of a logarithmic function here. Let's go and start filling this stuff out here. So a, just like every function we've done this year, okay, if a is less than 0, if it is a negative number, it is going to reflect across the x-axis, okay? So again, if you have a negative number way out front, it's going to reflect across the x-axis. Is everyone getting this down? In the back, y'all getting this down? But if a is between 0 and 1, sorry, if a is greater than 1, like 2, 3, 4, 5, 5.5, okay, it's a vertical stretch. And if a is some number between 0 and 1, it could be a decimal, it could be a fraction, but it has to be between 0 and 1. That's a vertical compression. Okay? This is literally what we've been talking about on every single function. The number out front always does those three things. Okay? So the new thing for today is this log thing, log. Don't worry about it. We'll talk about it more. But you got to have a base. So this little b, it's a subscript. Okay, that's your base. And then here's what we know about h. Literally the same stuff from the last one when we did exponential, from when we did quadratic, from when we did linear. Did we do linear? Okay. H is a lie. Let's go ahead and write that in here somewhere. Okay. Lies. Meaning, positive would be what you would normally think is negative. Negative is what you normally would think is positive. So a minus is going to shift it to the right. A positive is going to shift it to the left. Okay. And then, of course, like we were saying, k out to the right is normal, and it's vertical. It moves up or down. Okay. So make sure you have that written in so we can get down to the next part. All right. Everyone, make sure you got the k filled in. All these bubbles should be filled in. Done? Okay. Done? Done? Done, 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 done. I should bring my bass guitar. All right. Next slide. All right. So what is a logarithmic function? Okay. I don't have a copy of this. Is that what it asks? Y'all have examples. So you don't have to necessarily look at your paper because this is kind of a big picture thing. Logarithmic function. They are the inverses of exponential functions. So our last unit on exponential functions, if you remember, they would like kind of flatten out exponential decay or exponential growth. They would have a horizontal asymptote. Okay, if you had an inverse of that, you would get this logarithmic function. That's why this has a vertical asymptote. Okay, so check it out. The power to which a number must be raised in order to get some other number, which is a fancy way of saying how many of one number do you multiply to get another number? Now I'm going to just throw an example out at you, okay? Okay, 2 to what power is 8? How many times do you have to multiply 2 by itself to get 8? 3, right? 2 times 2 is 4, times 2 is 8. Okay, you're multiplying times itself. So when you're doing a logarithm, the answer to the logarithm is the exponent. Something to what power equals something else. Okay, it's kind of abstract to talk about without showing you an example, but we're just following these notes. Literally, here's the example I just said. So I got ahead of myself. So do you see how this says 2 to the power of 3 equals 8? This is how you would write it as a log. Okay. Now I want everyone to see how goofy this looks. Okay. The 2 is the base of the exponent, right? The 2 becomes the base of the log. So that kind of makes sense. The base is the base. But what's kind of goofy is that the 8 on the right side of the equation comes over into this parentheses, and the right side of the equation, the answer, is that exponent. See? Definitely write this down somewhere on your page, okay? Please write this down somewhere on your notes so you have an example of how to convert a logarithm. Maybe you could write it at the top right. There's kind of some space up here. Maybe off to the right. There's some space out here. And I'd like for you to write this down somewhere. We're going to get into converting these things in the next couple sections, but I want you to have this as like a primer, okay? Logarithms is kind of, it's like tying a shoe, but not really. All right, so does everyone have that written down? All right, cool. Next, okay? Check it out. when we said that logarithm is the inverse of exponential, I want you to see how these look, okay? On the left, we have a normal exponential function, base 2, 2 to the power of x, okay? On the right, we have a logarithmic function, base 2, log base 2 of x, okay? Do you see how they reflect across this diagonal line, y equals x, right? We know from past units that if it reflects across the line y equals x, it is a inverse function. So you can see visually this is an inverse function. You don't have to write it down, but I want you to see this, okay? Notice this blue one on the left has a horizontal asymptote that it's never going to touch. And this orangish one has a vertical asymptote that it's never going to touch, okay? So you can see how they have different asymptotes that they are approaching but not touching, okay? Okay, so these are different types of logarithmic functions. Again, you don't have to write this down until we get to these examples. But we have log base 2. This second one is called the natural log, which is log base e. And then you have just log x, which is an implied log base 10 of x. Okay? You have all these different logs. Where are they all going through at the same point? Okay, do you see how 1, 0 is a common point for all these different types of logarithmic functions? Okay, cool. All right. Here's some more information. The bases of logarithmic functions. The base of a logarithm can be only positive numbers not equal to 1. So whatever this little b is, has to be greater than 1. Can't be 1, can't be negative. Okay? If the base of the logarithm is greater than 1, it's increasing. Cool. But if the base is between 0 and 1, like a decimal or a fraction, 0.5, 1/3, something like that, then you're going to see it look like this right graph going down to the right, decreasing. So those are the different types of graphs you'll see, an increasing logarithm and a decreasing logarithm, okay? Well, back to this. We already talked about this. Let's talk about some examples, okay? So this says to write an equation for each description. So I want everybody in the back, hey, look up here, example 1. Example 1 says, the logarithmic parent graph with base 10 reflects the x-axis and vertically stretches by 3, okay? Now, whenever we have a log, we have a little number, the base, and it tells us, what's the base? 10. So you could put log x. Now, normally you would write the little 10, but if you don't write it, it's implied that it's a 10. So if you just put log x, we know it means base 10. Okay? That's our parent graph. Now, what do you think we're going to put on this to make it reflect over the x-axis? Okay? If you have a negative out front, that's going to reflect it over the x. Okay? Negative is right, and then when it says vertically stretching by 3, doesn't that make sense? Stretching by 3, you got to have a 3 out front. Okay? The negative is what reflects it. The 3 is what stretches it. Now, what about the next one? The logarithmic parent graph, base 1/2. Okay, so now we're going to have a little 1/2 as our little base here. Y'all see that little base 1/2? Right here. Okay. All right. Now, if I wanted to move left 4 and down 7, y'all remember, like we wrote down earlier, insiders lie horizontally. So I'm going to need to have like a left is usually negative, but it's a lie. So I'm going to have a +4, and then after that, down 7 is going to be plus or minus. Down -7. It'll have to have something like this in it, right? So when we write the answer, that's what it's going to be. You're going to have that log base 1/2 x plus 4 in parentheses means left 4 minus 7 means down 7. Okay? Do you see how you're taking a sentence, a description, applying what we know about these transformations and writing the equation? Okay? So remember, anytime it's a reflection, you got to have a negative. Vertical stretch is a number bigger than 1 in front. Vertical compression is a number smaller than 1 in front. Insiders lie horizontally. Outsiders are vertical. They do not lie. Okay? So, let's make sure we're on track with okay. Example number 2. Okay. Okay. Now, looking at this equation, what do you think the base is? Is the base the -3 or the 2? What do you think? Remember, base is the little number below the log. So yeah, base 2. And we literally just talked about this. That negative sign does what to that graph? It reflects it. Okay? So it's a reflection, and that 3 is greater than 1, so it's a vertical stretch. Reflect over the x, vertical stretch by 3. Okay. Now, the asymptote. Everybody, I want you to draw a line where the asymptote is. For me, it'll be in red. It's going to be vertically right here. Okay. Do y'all see that vertical line? What axis is it going through? It hits this one. The horizontal axis is called the x-axis, right? Since it goes through x, you're going to have to write x equals, you can go ahead and write that, x equals, and what number does it go through right there? The red dashed line goes through 0, right? So x equals 0 is my vertical line going through the origin, okay? Now, go ahead and plot those points. They're multiplied by 3, they're stretched out, and they're flipped over, okay? So you have a point right here at 1, 0. You have another point at 2, -3, and another point at 4, -6. All right. So plot those points and draw your logarithmic function. Is everyone doing this right here? Let's think about the domain and range, okay? So the domain, how far, and by the way, which direction is domain? Let's impress an Algebra 1 teacher here, right? That y'all know domain and range. Which way is domain? Left and right. From left to right, okay? Now you tell me, how far to the left is this graph going? We just drew this line that it can't cross, right? So it's not going to the left forever. It's stopping at what number? 0, right? You get so close to 0, okay? Uncomfortably close, but it's not touching 0, okay? So since domain is x, go and write x for your domain, okay? Would you say that it is greater or less than if it's going to the right? Horizontally, to the right is greater, okay? So we can say x is greater than, what number is this again? 0, okay? X is greater than 0. But what about the range? So if you look at it, this does keep going down, 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 and it will keep going down, down, down. It goes up, 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 it'll keep going up, 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 okay? Hopefully we know range is y, and it's vertical, and it's from bottom to top. So many times I hear people saying top to bottom, okay, bottom to top. But yes, this is all real numbers. Okay, you can write that little weird r, you can put negative infinity to positive infinity if you want, but we like to do the all real numbers because it's less running. Okay, let's do example 2b. What is the base? What's the little number next to log? 1/2, right? So I got my half base. Okay, now there's nothing in front of the log to the left of it, so let's go to the insider. If the insider is +4, what do we know about insiders? Liars! Okay, and it's horizontal. So which way is +4 really going? Left 4. It's like a negative, so it's left 4. And then the -3 is going which way? Up or down, left or right? What do you think? Down 3, okay? So left 4, down 3. Go ahead and write that down. No pun intended. What do you think about the asymptote? Now, before we think about asymptote, why don't you take those 3 points, move them left 4 and down 3? If I take each one of these points and go left 4, down 3, left 4, down 3, left 4, down 3, plot those new 3 points and draw your new vertical asymptote. Okay? Is everyone seeing that this is where my new vertical asymptote is? Right here. Okay, so again, make sure you got these graphs. This is our last example. Stay with me, okay? The backside is a key or what do you call it? Some examples that you can look back on. But we're just together. We're going to finish this example 2b. The asymptote, again, the vertical asymptote. What do we always write for it? Just like the last time? X equals, but this time, since it moved to the left 4, where's my new vertical asymptote? -4, okay? So now for my asymptote, I'm going to look at the number on the insider, and remember it's a lie, okay? So we always write X equals, and it is -4 because it moved to the left 4, okay? So again, that insider tells you 2 things, the horizontal shift and the asymptote, and it's also going to help us with the domain here in a second, okay? Now let's think about domain. Is this graph going less than or greater than -4? To the right is greater than, so we're going to write X greater than -4. Not equal to, not underlined, because it does not touch that line. It's an asymptote. Do not touch the asymptote. Okay, now, range. Just like last time, it's going up and down forever. This one's also going up and down forever. You can go ahead and write the weird looking R for all real numbers, okay? As you're getting this written down in the back, hey, wake up. As you're getting this written down, okay, your 10.1 assignment will be similar to this. I'm going to pass that out, or someone's going to pass that out for you. And it has the big 10.1 in the top right corner. Please use these notes as a reference. The reason why we do them is to help you with it, okay? The only other thing on our notes is this last slide, which is not on the PowerPoint, but as you can see here, check it out. Here's some examples of turning exponential into logarithmic, which we're going to get into in the future notes, okay? But we're going to pass out 10.1. I want you to start 10.1. We'll have some time tomorrow to finish as well, but I want you to start today. If you have any leftover Unit 9 assignments, you should get those turned in as well, okay? All right, here we go.